Welcome back to the Deep Dive. Today, we're plunging into a really innovative area. It's a new AI hybrid Solana decentralized application,
Yeah.
Adopt ecosystem.
Yeah, it's pretty cutting edge stuff.
Definitely. And it promises to, shake up how we think about token launches, maybe even trading.
Mm.
So our mission today, we want to unpack exactly how the system works. We've got this detailed white paper as our source,
Mm-hmm.
and we're going to reveal the, surprising way it combines the rock-solid rules of blockchain with the, let's say, adaptive intelligence of AI.
That's a good way to put it.
Think of this as your fast track for you listening to understanding what could be the next big thing in decentralized finance.
So at its core, the big innovation here is really the seamless integration. You've got the deterministic logic on-chain built on Solana, very reliable, working hand in hand with intelligent AI-driven decisions happening off-chain.
Off-chain using the Gemini 2.5 Pro API, right?
Yeah. Exactly, leveraging that power. So this isn't like your usual static, rigid system. It creates something responsive, optimized, even automated. Key economic parameters aren't just fixed. They're dynamically managed by the AI.
That sounds really powerful. So what's the fundamental problem this hybrid model actually solves? Why do we need this? How does it make dApps more, adaptive? Let's get into it.
Well, the thing with traditional dApps is their deterministic nature. They run on these very rigid, predefined rules. Now, that's great for security, for predictability, which is, fundamental to blockchain.
Sure, you want that certainty.
Exactly. But it also means they can struggle to adapt quickly when market conditions change or when you have really complex economic situations. That inflexibility, that's really where this hybrid model comes in.
Right, okay. And that's where this hybrid architecture concept becomes a solution. It sounds like a separation of duties almost.
Precisely, a clear separation. On one side, you've got the on-chain Solana programs. Think of these as the source of truth, maybe the brawn of the operation.
It's the muscle.
Yeah, the muscle. They securely hold all the assets, the SOL tokens, other SPL tokens, inside what are called program-derived accounts, PDAs.
Okay, wait a sec. PDAs, for anyone maybe not deep into Solana.
Good question. Right. So program-derived accounts, PDAs, think of them like special digital vaults. They're controlled by the Solana programs themselves, not by a person's private key.
Ah, okay. So the code controls the funds directly.
Exactly. That's crucial for securely holding the project's funds, the tokens, letting the programs manage assets without needing trust. So these on-chain programs, they enforce all the rules, execute transactions atomically, meaning they either fully complete or don't happen at all.
Got it. Immutable, trustless execution, the blockchain basics.
Correct. Then on the other side, you have the off-chain AI bots. These are their brains.
The intelligence layer.
Exactly. These bots, they run on external servers. Their job, constantly read the state of those on-chain programs. They package up that data, send it off to the Gemini 2.5 Pro API for some serious analysis, some intelligent decision-making. And then based on what the AI suggests, they submit transactions back to the blockchain. And those transactions update key economic parameters dynamically.
Wow, okay, so it's a continuous loop. Read, analyze, update.
Pretty much.
So we're really talking about a whole system, and it's, 3 on-chain programs and 2 off-chain AI bots, all working together for token launches and trading.
That's the setup described, yes. A full platform.
Okay, let's break down those on-chain pieces then. The Solana pillars. You mentioned they're distinct programs written in Rust using the Anchor framework.
Yes, Anchor is a very popular framework in the Solana ecosystem. Makes building these complex, secure programs quite a bit easier and safer.
Gotcha. So, first pillar.
First up, the ICO Launchpad. Its codename is Factory Program. Its main purpose is, pretty straightforward. Let a project create and sell a new token. An initial coin offering, essentially.
Right. And how does it do the selling part?
It uses something called a bonding curve. This is pretty interesting. It means the token price isn't just fixed. It's calculated by a formula, a linear one in this case. The current price equals some initial price plus a slope multiplied by the number of tokens sold.
Okay, so simple terms, the more people buy, the higher the price gets automatically.
Exactly. It builds in that upward pressure as demand increases. Can be a good incentive for early buyers.
Makes sense.
And this program, it uses a PDA, again called launch state, to hold its configuration. Things like who the authority is, the token details, that initial price and slope, and crucially, a counter for tokens sold.
And the actions it can perform. instructions, you call them.
Right, the key instructions. There's create launch, obviously, to set everything up, create the new token. Then buy tokens, that's the main one for users. Send SOL, get tokens back. And importantly, this buy tokens instruction can trigger something called a cross-program invocation, a CPI,
TPI.
to the affiliate program if someone used a referral link.
Okay, hold on. CPI cross-program invocation. What is that functionally?
Think of it like one smart contract securely calling another smart contract on Solana. Program A tells Program B, hey, do this specific thing for me. It lets these different parts of the application talk to each other directly and trustlessly on the blockchain.
Got it. Like internal phone calls between programs.
It's a good analogy. And there's also a withdraw sol instruction, so the project team can actually get the SOL that's been raised.
Okay, that covers the Launchpad. What's the next on-chain piece? The affiliate system.
Yes, the affiliate system or affiliate program. This manages, well, an on-chain affiliate system. It allows people, third parties, to earn commissions if they refer buyers to the token sale.
Like a standard web affiliate program, but built on-chain.
Pretty much the same concept, yeah. Each affiliate has their data stored in an affiliate info PDA. That holds their public key, obviously, the total referred volume they've generated, and their commission rate.
It's basis points.
Basis points, yes. So 100 basis points is 1%. A rate of, say, 1,000 BPs would be a 10% commission. And here's the really crucial part, the AI connection. This commission rate, TEPS, this is the value that the AI bot, the optimizer bot, can change.
So the AI is tuning the affiliate rewards directly.
Directly. The program has instructions like register affiliate, anyone can sign up. It has process commission, which is only callable via CPI from the factory program during a referred purchase. It calculates and mints the commission tokens straight to the affiliate.
Seamless.
And then there's set commission rate. This is the AI hook. It's permissioned, meaning only a specific authority, in this case, the off-chain optimizer bot, can call it to update an affiliate's commission rate based on the AI's analysis and suggestion.
Interesting. Very dynamic. Okay, and the third on-chain program, the DAX.
Right, the Barter DX, the Barter DEX program. It's described as a novel, Oracle-based, decentralized exchange.
Oracle-based. How's that different from, say, a typical AMM like Uniswap or Serum?
Big difference. Most AMs, automated market makers, use internal pricing formulas. You know, the classic Liskay or more complex variants. They figure out the price based on the ratio of assets in their own pools.
Right. Self-contained pricing.
This Barter DX, totally different. It relies entirely on an external price feed. That feed comes from a trusted oracle. And in this system, that oracle is the off-chain AI bot, the price keeper bot.
So the AI dictates the price for swaps on this DX.
Correct. The liquidity pool PDA for this DX stores the info about the two tokens being traded, Minta, Minta, the Oracle authority, which is designated as the price keeper bot's key, the Oracle price itself.
Which is the AI-generated price.
Yes, the AI-generated price stored with 9 decimals of precision, very granular, and also a last historic loop date timestamp. That's important to prevent people trading against a price that's too old, too stale.
That reliance on an external oracle, especially an AI one, is definitely novel for a DAX. It sounds like it gives you that AI flexibility, but doesn't that also bring in a different kind of trust assumption compared to a pure AMM? What about, the oracle being wrong or manipulated or the AI having biases?
That's a very sharp point, and yeah, it's a key consideration. The security model here shifts. Instead of trusting the internal math of an AMM, you're trusting the designated oracle authority, which is the price keeper bot.
So you trust the bot and the AI behind it to provide a fair price.
Essentially, yes. The white paper frames the bot's role as determining fair market value via its prompts to Gemini. But any external oracle, AI-driven or not, introduces that dependency. The design assumes the bot and the AI process are secure and robust enough to resist manipulation because, yeah, their output directly sets the on-chain swap prices. It's a different trade-off.
Okay. And the key instructions for this DX?
There's create pool for setting up a new trading pair. Then, critically, update your oracle price. This is the other main AI hook. It's permission. Only the pricekeeper bot can call this to push the latest AI-generated exchange rate onto the blockchain for that pool.
Updating the official price.
Exactly. And then, of course, swap. That's for users. They want to trade token A for token B. The amount they get is calculated directly using that oracle price. And it has built-in checks. It can fail with an oracle price stale error if the price hasn't been updated recently, or insufficient liquidity if the pool just doesn't have the tokens needed for the swap.
Right, basic safety checks. Okay, so that covers the on-chain foundations, the brawn, as you put it. Now let's flip to the brains, the off-chain AI components. You said these are Rust apps using libraries like Request for Web Calls and Anchor Client to talk to Solana.
That's right. Request handles the communication with the Gemini API over HTTP, and Anchor Client makes it easy for these off-chain Rust programs to interact with the on-chain Anchor programs we just discussed, constructing transactions, reading state, all that.
So first, AI Brain, the optimizer bot.
Yes, the
Uh-huh.
optimizer bot. Its main goal is dynamic management of those affiliate commission rates we talked about. It's not just setting a rate and forgetting it.
Right, it's about adjustment.
Exactly. It's designed to intelligently reward the affiliates who are performing well, bringing in lots of volume, maybe bumping up their rates. And conversely, for affiliates who aren't performing, it might optimize costs by potentially lowering their rates.
So it's active economic management based on performance.
Precisely. And the really clever part isn't just setting the rates, it's that feedback loop. The system is designed to learn and adapt its incentives constantly in near real time, that kind of dynamic optimization. Very hard, maybe impossible, to do with purely on-chain deterministic logic.
Okay, walk us through its workflow. How does it actually do that?
It's quite methodical. Step 1, fetch data. It queries the affiliate program on Solana, reads the current affiliate info for various affiliates, what's their volume, what's their current commission rate.
Gets the current picture.
Yep. Step 2, query AI. It takes that data and constructs a detailed prompt for the Gemini 2.5 Pro API. It essentially tells the AI, okay, act like a Solana tokenomics expert. Based on this affiliate's performance data, suggest an optimal new commission rate in basis points.
Gives the AI context and a clear task.
Exactly. Step 3, parse response. The AI sends back its suggestion, usually in a JSON format. The bot parses this response to pull out the specific number, the suggested new attempts.
Finds the number it needs.
Right. And finally, step 4, submit transaction. If, and only if, the AI's suggested rate is different from the affiliate's current rate.
No point updating if it's the same.
Right. If it's different, the bot builds a Solana transaction to call the set commission rate instruction on the affiliate program, signs it with its authority key, and sends it off to the network. The affiliate's rate gets updated on-chain.
A very neat automated loop.
Hmm.
Okay, and the second AI brain, the Pricekeeper bot.
The Pricekeeper bot. This one acts as that decentralized price oracle for the BarterDEX program. Its whole job is to figure out and maintain what the system considers a fair market value for the token pairs being traded on the DAX.
So similar workflow to the optimizer bot.
Very similar logic, yes. Step 1, fetch data. It queries the BarterDEX program to see which liquidity pools are active and what the token mint addresses are for each pair.
Knows what prices it needs to find.
Correct. Step 2, query AI. It crafts a prompt for Gemini, but this time instructing it to act like a decentralized exchange price oracle. The task is determine the fair market exchange rate between token A and token B right now.
Asking the AI for the current market price.
Pretty much. Step 3, parse response. It gets the AI's response, again likely JSON, and extracts the price of Fein B. And remember, this is formatted as a precise integer with 9 decimal places.
It gets the price number.
Yep. Step 4, submit transaction. It bills, signs, and sends a transaction to the BarterDEX program, specifically targeting the update oracle price instruction for the relevant pool. This pushes the new AI-determined price onto the blockchain.
And that becomes the price everyone uses for swaps until the next update.
Exactly. It ensures that DAX is always operating or trying to operate based on the AI's latest assessment of fair value.
Okay, so let's just take a step back here. What we've really looked at today is this pioneering hybrid DApp architecture. It seems to genuinely blend the trustless nature of smart contracts with the adaptive smarts of LLMs. Quite a combination.
It really is. And the power of this approach, I think, lies in delegating those really complex, sometimes subjective economic decisions like, what's the optimal fee right now? What is fair market value in a volatile market?
Yeah.
Delegating those to an off-chain AI.
Things that are hard to code rigidly.
Extremely hard. Trying to anticipate every market condition or strategic nuance in advance and hard-code it into a smart contract, it's practically impossible to do well and keep updated. This approach frees the blockchain to focus on what it's best at, enforcing rules, securing assets, providing that immutable ledger. Meanwhile, the AI handles the complex real-time adaptation and optimization.
So this model, it really offers a kind of blueprint, doesn't it, for creating systems that aren't just decentralized, but also more dynamic, more efficient, maybe even more intelligent.
I think intelligent is the right word. It points towards a future where decentralized systems can react and optimize in ways that Purely deterministic ones simply can't.
Which definitely leads to a final thought, something for you, the listener, to consider. As AI gets woven more deeply into blockchain, how might that change how we even understand what a decentralized system can be?
That's a big question.
Yeah.